Hey guys, well I think I've had a bit of an introduction already. I'm Werner. As mentioned, I'm a software engineer here at BBD. I am actually from Cape Town, flew in today. I work there on a project called Throughput. They do kind of online betting, and we've been using Docker quite vigorously within a Kubernetes environment there, and I'd like to share some of the insights that I've gained in the past 2 years on the project. So yeah, that's me in Santa Monica Beach, just after reInvent, representing Docker and South Africa. And this is BBD, where we all are at the moment. All right, so let's talk about why we're actually here. We want to speak about Docker, right? So Docker now is roughly, I think Docker is now roughly 5 years old. I think it was released in 2013, and I can still remember to this day the first time that I was introduced to Docker. It was also at one of these meetup groups, but it was one of the open source meetup groups at the Gautrain station in Pretoria back in 2014. I remember listening to this guy speak about Docker, and I have no idea what it was, even after him explaining it to me. And probably around 2 years ago, as we started on this new project that I just mentioned, I got reintroduced to Docker. And I must say, I really, really liked what Docker could bring to the playing field. So what is Docker used for? It's very popular in the space of application portability. This becomes very prominent if you want to perhaps build applications that run in some cloud, so Amazon Web Services, or perhaps on-prem on virtual machines, on some kind of hypervisor. It also simplifies DevOps a lot. And by DevOps, I mean it's often very, very, very hard and very time-consuming to link up all of these components together in order to build full CI/CD pipelines. Like, for example, TeamCity or Jenkins. I don't now have to go onto a virtual machine and install everything that I need. I can just say Docker run my Jenkins agent, Docker run my Jenkins server, and it's kind of all there for you. I don't have to care about that installation cost. It also, with a pinch of salt, gives you reliable deployments, or let's rather say more reliable deployments. Back in the day, if, let's say, I was developing an application that had a dependency on a very specific version of some runtime library, like Python, for example, I needed to make sure that all of the dependencies for this application outside of the actual code was present on the machine that I was running this on. But now Docker abstracts that away from you because I kind of now have this deterministic runtime environment. I know that it'll always run the same with a pinch of salt. And it also becomes very useful for distributed applications. People have been using Docker a lot for building systems following the microservices architecture because of the fact that you get these kind of modularized, isolated processes and environments that you can link up together. But Docker, as any process, also needs some resources. One of the main ones is obviously memory, also CPU, and networking. So how does Docker actually deal with managing memory or setting limits on it? It does it with flags. Fun with flags. So you can specify memory as a runtime argument of whichever amount of memory that you want. And this is a hard limit. So the Docker container won't actually use more than that. You can specify kernel memory. This is a bit different than the actual memory flag because of the fact that kernel memory is not swappable, right? And you can also specify memory reservation. So this is a type of soft limit with regards to the higher limit that you set on the memory. So memory reservation will only take place when the host actually has memory contention. If it's running out of memory, this is kind of a soft limit. And then, of course, the thing that needs the most amount of resources, BusyBox. Same thing with CPU, just with a few different flags. So I can specify the amount of cores that I need by passing a runtime argument. And I can also specify the amounts of CPU shares. So in other words, the kind of amounts of CPU cycles or that I can run. And again, BusyBox.
How does that CPU shares work across the host?
So CPU shares is a kind of relative argument that you give.
So you set all the Dockers to the same, they get the same?
Yes. So if it defaults to 1024, and then if you specify 1024 for one Docker container and through whichever higher number, when CPU contention starts happening, then it'll start to prioritize the one with a higher relevance. Okay. So now we get to network throughput. So there's no flags for this, and it kind of makes sense. If you want to throttle or rate limit the networking throughput of your containers, that's kind of not within the domain of the containers. I've read some interesting articles where people have proposed some solutions towards this, but as far as I know, up to now, Docker doesn't actually support this. But Docker does support some configurations, right? So by default, when you install Docker, you get 3 different networking options. You get the bridge network, which is the default. That is where you say localhost 5050 to whichever port the container is running on. That's using the Docker NAT. The other option is using the host machine network without using a private subnet where this whole port mapping takes place. And of course, none. So I've also read a few kind of empirical analysis on the performance of these, but obviously if you use a host network, you're using the network interface of the host machine, so it's primitive performance. Whereas with the Docker NAT, some people have reported kind of single-digit millisecond, if that much, latency increases. But now I have this container. Docker is great, runs one container perfectly. But what happens if I have 6,240 containers? It starts getting a bit of an issue to manage them. And there are quite a few different technologies that have been introduced to kind of deal with this problem. One of these is Docker Compose, which makes it easy for you to link up your containers. It's very popular for kind of non-production environments where I want to just see, okay, I need this service to speak to a database, which also has a dependency of some other process that I need to run. Also Docker Swarm, which I will be speaking about in the talk just after this one. And of course, Kubernetes. There are obviously various other ones as well. So let's speak a bit more about Kubernetes. The Kubernetes platform is open source and it's backed by Google. And it manages your container deployments for you. So instead of doing a Docker run, I specify in some kind of configuration, which they call Kubernetes manifests, that I want to run this container with this configuration. And it manages a little bit more than just running your application for you. It manages the fact that, okay, I want to run 3 and 4 of them, and as I deploy them, I can deploy them in a rolling update fashion, or I can deploy them using a variety of strategies. It also makes scaling of containers easier. So if I have one container and I need to horizontally scale, I can automatically scale this with Kubernetes, or I can specifically tell it I want 4 or 5 of these containers to run in parallel. And if you go Google around a bit on Kubernetes, they always advertise management of containerized applications. But what does management actually entail? So some of the few important features that Kubernetes does in terms of management for the containers is something like, for example, deciding where to actually run the containers. So if I specify a container to use at maximum 2 gigabytes of memory, I don't ideally want to run that container on a host that only has 1 gigabyte of memory available. So Kubernetes has this scheduler which will do that kind of resource accounting for you and decide where to place your Docker containers. It also acts as a storage facade, where you have what they call persistent volume claims and persistent volumes, which map to a variety of different storage backends. So if that's in Amazon Web Services or Google Cloud or Azure, it's kind of the same interface for you to use. It also does service discovery for you. So you can kind of see this as resource management if you regard a service to be an actual resource. But most importantly, or very importantly, probably not most, but is resource management. So as I've mentioned, Kubernetes uses manifests to specify which containers to run. And in these manifests, you set the allocation strategies for the Docker containers. As I've mentioned about Kubernetes deciding where to place these pods in your whole cluster of hosts, you can specify some very interesting things, such as, I want this container to only run on a host that is in Google Cloud, or only on a host that is in Amazon Web Services. Perhaps the Docker container has a bit of needs more CPU. So then I would want to run that on a CPU optimized host in comparison to just a general web server. This is a typical example of what a Kubernetes manifest looks like. So there's a whole bunch of information here, but the thing that we're actually really interested in is the containers part there at the bottom. So this is YAML. I'm sure many of you guys have dealt with YAML before. And this is just a list of all the containers that I want to run as part of this deployment. So how does one specify the limits of a Docker container in Kubernetes? So of that spec, that YAML file that I just showed you, you just add resources limit CPU and then the value that you want. So what Kubernetes will do is it'll take that value that you specified in the Kubernetes manifest and map that onto flags that we've discussed earlier. So if I put that as 1024, that will be translated as Docker run CPUs equals this amount. Same for the requests, the CPU. So I was actually on a bit of a misconception around the limits and the requests of a Docker container. So the requests kind of is a minimal guarantee under load, right? It's not like I now request one core and that core is only used for me ever. It's kind of, as I mentioned earlier, a relative amount in comparison to the other containers that are running. Same thing for memory. By specifying the limit, I translate that into a flag called --memory. And if I specify the request, that then translates into the memory reservation. So this is a typical example of a bunch of containers where I have specified these requests. As you can see, for the MySQL database, I'm requesting at least 64 megabytes of memory, and I have a limit of up to 128 megabytes of memory. But now the question kind of comes up, what happens when these resources reach their limits? So Kubernetes and Docker, they just have different words for it, have this concept of compressible resources. So an example of this is your CPU. If the limit that you've imposed on that Docker container reaches the limit that you specified, then it'll only be throttled. It'll just work a little bit slower. But if you look at incompressible resources, something like memory, if that is reached, you get a SIG term. The Linux operating system will actually kill that process. So it's a bit scary to think that if your application uses a bit too much memory, your users can actually experience downtime. So now, given the fact that you have all of these limits in place, how do I guarantee service? Or how do I orchestrate the various containers in such a way that I am maximizing, or not necessarily maximizing, but kind of optimizing the way that I want the containers to run. So Kubernetes provides for a whole bunch of different quality of service classes. The first one, which is guaranteed, kind of is the strongest guarantee of quality of service. Then you get burstable, as well as best effort. So the guaranteed quality of service, as I said, it takes top priority. This will be the case if, for a specific Docker container, I've specified that the CPU limit and the CPU request is exactly the same thing. So I absolutely want 2 cores on this Docker container. Same for the memory limits. I absolutely need 512 megabytes of memory on this Docker container, irrespective of if this is under load or not. And this is the top priority quality of service guarantee. This, if you think of all of the containers running on a specific host, the guaranteed quality of service containers will be the last to be evicted or killed by the Kubernetes scheduler. So just something to remember if you're using Kubernetes. If you only specify the limit, the request is inferred to be the same amount as the limit. So for anything where you just specify limits, it will be a quality of service, a guaranteed quality of service. As for the burstable one, this can be very useful. This is the case where if the limit of the CPU exceeds the request of the CPU, or the memory limit is more than the request limit. And at least one of these is present. So I need to tell the container that, okay, cool, you need a minimum, essentially, of 256 megabytes, but you're only allowed to use a maximum of 512, and you're allowed to burst that little bit between the ranges that I've specified. This is kind of the middle one. Containers with the quality of service of burstable will be killed before containers with the quality of service of guaranteed. And this is a minimal resource guarantee. It's completely possible that on a specific host, I have 5 containers, and they all request at least 512 megabytes of memory, but the limits specified actually exceed the capacity of the host. So if it is the case that all of them burst at the same time, I can still get into the situation where the host is completely overutilized. And then, of course, best effort. So this is the case where no requests or limits are specified. So this is literally running Docker run without specifying anything. And by default, Docker will not limit you in terms of the memory and the CPU allocated to the specific container. This takes the lowest priority. So if I have a host with a whole bunch of different containers running with different quality of services, these containers are the ones that will be killed first to free up resources. So in Kubernetes 1.8, they also introduce other types of storage limits. So something that I neglected to mention was another computational resource that we often use is disk. And Docker containers use ephemeral storage, or they can mount onto whichever storage provider there is present, so be that an EBS volume or your hard disk on your computer. So Kubernetes 1.8 has now introduced ephemeral storage limits, where you can regulate the amount of storage that a Docker container is allowed to write to its writable layer. If the container's writable layer of storage is exceeded, so if it's logging a whole bunch, then it will be killed. And when that is killed, that storage is then freed up again because of the fact that it's ephemeral. And something very interesting, they've now brought out support for extended resources, for custom metrics. So if I perhaps want to measure some arbitrary metric and use the same resource accounting algorithms that Kubernetes has implemented, I now have the freedom to do that, be that whatever it may be. Perhaps networking, because of the fact that you kind of need third-party tools to be able to rate limit or scale down the throughput of network traffic to your containers. That might be an interesting option. But now, given the fact that I've specified all of these limits on the containers and everything's running fine, how do I actually monitor that the state or the kind of greediness of these containers? Docker exposes an API where you can get very detailed information around the statistics of a running container. And there's an open source tool called CAdvisor, which works pretty well. It's actually baked into the Kubernetes kubelet, which is the kind of management process on each of the Kubernetes nodes. What this does is it just interrogates the Docker containers for their statistics and then gives you visualizations of that. And there are so many products that you can use to gain insight into the functioning of your containers. Stuff like Heapster, InfluxDB, Grafana, Prometheus, Datadog. All of them, some of them work in conjunction with with the others, but something like Datadog proprietary, but it's pretty cool, the kind of insights that you can get into the containers that you have that are running. So, some of my tips for running containers. So, it's important to run the applications that are containerized on appropriate hosts and isolated hosts. So, you don't want in a Kubernetes environment or a clustered host environment, be it Kubernetes or not, that if a application is killing the node, if it's killing the host, you don't want your monitoring to go down, right? You want to be informed of the fact that, hey, listen, my stuff actually broke. But if you're running all of those containers on the same thing and that one host dies, you just lost your monitoring together with your applications. Set up alerts for containers that reach their limits often, right? This is very important because if you specify that this thing is only allowed to use 2 cores of CPU, but actually it can burst a little bit more, or perhaps the load is on such a level that I'm throttling this thing the whole time, and I'm experiencing bad performance, but I don't really know why, because everything seems healthy, right? You can with something like Prometheus, for example, interrogating the API server from Kubernetes, specify, check what the CPU usage is, and compare that with the limit that is imposed on it. And most importantly, don't guess resource requirements. You can kind of thumbsuck it. I mean, a lot of us do. But you really should be doing load testing. You really should be knowing and understanding the requirements that your applications have. And something that broke me a few times, always use tagged containers. If you use latest, it auto upgrades whenever you restart it. Not fun if you're going major versions up and suddenly everything is breaking. And then also, don't be overly generous to container resources. Remember, this is limits. It's completely possible that I'm now running 4 or 5 containers on a host, but the host is actually using 2% of the CPU, right? You don't want to give too much or too little. That's why I'm saying understand your resource requirements. And then some final words. As I've mentioned, Docker has no limits by default. If you're running in prod, it's probably a good idea to go have a look at some resource management techniques. And if you're running Kubernetes, some Kubernetes clusters give a lot of responsibility to containers. If you're using something like container networking interfaces, something like Weave or Flannel, if your Docker container dies because of the fact that you're overutilizing your resources, everything dies. You can't access those containers anymore. Kubeproxy. If I want to do load balancing between applications in my Kubernetes cluster, the thing that does the load balancing is the DNS, which is also a container that runs, as well as kubeproxy. And as I've mentioned, monitoring. Also have a look at the Kubernetes Docker integration. I saw that it's now in beta. I haven't played with it myself, but I think it's quite an interesting thing to have a look at. And that's all, folks. Thank you for listening to me. Cheers.